if a car doesn't have a differential. During running, it might be like what's happening on the left. But why does this occur? When a car is turning, the outer wheels travel a greater distance than the inner wheels. The inner wheels have to move slower than the outer ones. Without a differential to adjust both sides, the inner wheels would slip, resulting in loss of control and rollovers. So, how does a differential work? Imagine there are two wheels. They can each spin freely. Now we attach a strip to each of their axles. Using these strips, we can rotate the left and right wheels separately. But can we make both wheels rotate together? That's easy, just add a crossbar in the middle, like this. Now, with the crossbar, we can make both wheels spin together. But how do we keep the crossbar in place? It's quite simple. We add a connecting rod to one wheel's axle and connect it to the strip. This secures the crossbar. Now here's the thing. With this setup, both wheels will rotate at the same speed. However, they can still slip during turns. So what's the solution? We can install a bearing in the middle of the crossbar and make the crossbar rotate freely. During a turn, the faster wheel will make the crossbar rotate. This allows both wheels to maintain their own speeds, thus preventing slipping. But there's still a challenge. If the wheel speeds differ too much, a situation like this can occur. So how do we resolve it? We can add more crossbars, like this. This ensures that power can be smoothly transmitted to the wheels. Even if one set of wheels isn't turning, the other set can still operate. But there's one more challenge. This method can lead to uneven distribution. So to address this, we increase the density of the crossbars, like this. In reality, this is how a car's differential works. The only difference is that both the strip and the crossbar have been replaced with gears, and additional upgrades have been made. Now let's take a closer look at the specific upgrade process. First, power comes from the engine. It's transmitted through a small gear at the end of the drive shaft. This power is then transferred to a ring gear. Attached to the ring gear is a planetary gear. The planetary gear not only revolves with the ring gear, but can also rotate on its own when external forces are applied. On top of the planetary gear, there are two side gears in mesh. These two side gears are connected to two wheel axles, respectively. The engine's power first reaches the gear on the drive shaft, then it comes to the ring gear. Next, it engages with the planetary gear. Finally, it drives the side gears and the wheels. To ensure effective transmission, on the opposite side of the planetary gear, there is another planetary gear. Now, let's visualize how the differential works. If the car is moving straight, you can see that. Apart from the connection, the small gear on the drive shaft and the ring gear are rotating. But if the car turns left, all the gears start to rotate. However, if the car turns to the right, all the gears start to rotate. And you can see, the left wheel axle gear is obviously turning slower than the right one. The same happens when the car turns right. All the gears start to rotate, and the left wheel axle gear is obviously turning faster than the right one. This is how the differential helps you make smooth turns.